Okay, we ready to get started? You go back here. We talked about this company. They're getting into golf bags, right? They said we're going to make standard golf bags, we're going to make deluxe golf bags. And they went through the whole thing here. They made some models of it. And then they go here and they said, here's how much time. We went ahead and made enough of these golf bags and know this will be the average amount of time in each department for each golf bag. And then we looked at this. This is all review, right? You guys with me? And then we looked at this and they said, there's only so many hours in each department. Your mind should go limitations. Limitations. And as soon as you read something you think is a limitation, that's a constraint. That's the indicator. And I told you I always start with, once I read a limitation, I'll write the right-hand side of the constraint. And it's going to be a less than equal, greater than equal, or equal, right? So there's all that. And then this is, without the words, and if this is a quiz or a final exam, there would be additional words here. But this says, the accounting department analyzed the production data and arrived at the prices for both bags, and the results will be profit for a standard bag will be $10. Profit for a deluxe bag will be $9. And then if this were a quiz, it will say, and the company would like to get as much profit as possible. That is the objective function. When you read something like that. Max or min, what do we do with this one? Max, because it's profit. When you're reading this, you got to get in the mind as the manager. You got to say, what I want this to be as much as possible or as little as possible. And if it's a cost, you know it's a min then. Profit, revenue, something good if you're a manager of this company would be a max. Something you want to keep control of and low would be a min. So we wrote our objective function and all our constraints, right? We did all this, we understood how to do this, but then we got into the graphing. Did you do this one?
Yes.
You did? Talk me through it. I just want to review the graphing a little bit. We're trying to get 2 points, right? And one of them, let's see, what is this? Is this my S standard? We'll make this one, well, this is even before this one. This is another one. We're going to make S a 0 and figure out what D is. And then we're going to make D a 0 and figure out what S is. All right? Jump into it.
When you get a question like this, if it has no words, how do you know which one is X?
I know that makes it hard. Which one's what?
Like, so you just picked an X and Y, right? But how did you know which one's X and Y?
Everybody in here could use different variables, not just X and Y. And
but for your axes. So you chose that S would be on the
if you accidentally do it the other way, I'm fine with that. But in mathematics, the left-hand one always represents the horizontal axis.
So you picked that because it's the leftmost variable?
And it was just the first variable. I could have put D here and S here, but then this would be D and that would be S. And that's fine. And I don't mind if someone does it the other way. I mean, I can see, oh, you did it this way. It's not wrong. It's just they had to use the different axes.
Okay.
It's still right.
You just have to be...
Yes.
Okay.
So I put a 0 in for S right here. 0 times 10 is 0. I divide both sides by 9. Now, 600. Yeah. Look at somebody jumped in on your job. I'm going to make D 0 and S is there. Divide both sides by 10. This is obviously 540. And you would graph those 2 points. This would be on the vertical axis. This one would be on the horizontal axis. And you would connect those points. That graph is not that. Put that graph there for probably coming up on. And it would look like this. If this were. This one, we put a 0 in for S, divide both sides by 1, we get 630. Put a 0 in for D, we divided both sides by 7/10, and we got, is that 900?
Yeah.
900. Connect them, even go a little past if you can. Now, we're at the point where I hope everybody can graph a line like this. Now, we got into shading a little bit. I want to make sure you remember. Once you have the line, you go back and go, I'll pick a point on either side of the line, and I told you for me, going right down here is always the easiest. 1, 1, or 100, 100, or something like that. And then you plug it into the constraint. Let's say we went 100, 100, 100, and 100. Is it true? Will this end up being less than or equal to 630?
Yes.
100 times that? 70. 100 times that? 100 plus 70? 170, is it less than or equal to 630? Then that is the direction you should be shading. Now, if someone else said, I'm going to pick a point out here, and they plug it in, they're going to realize it's not less than or equal to 630, and it's trying to tell you, don't shade that direction, and you don't need to do any more math, you know to go the opposite way. This one had 4 constraints, so you'd have to grab all 4 lines, and sometimes you want to keep the shading light until you figure out the feasible region. I've even had students do this, and this is fine, I want to show you. They'll take arrows in the direction of the shading before they even shade, so they can focus on where they all overlap, and a lot of students will just shade the overlapping area. So you graph each one of these on one graph, not 3 separate graphs. You graph each one of them, and they're all on top of each other. And then you go, where are all of the shadings, not just 3 of the 4 or 2 of the 4, all 4 shades must be overlapping to be the feasible region. And it looks like this. All these shades were going this way. Look at that little triangle there. That is not part of the feasible region because this constraint goes this way and would not be part of overlapping in that little spot right there. And now, Trevor, this is you again. How many extreme points?
So you said 1, 2, 3, 4, 5.
5. Exactly. And the one everybody was missing Tuesday was, that is a point also. It's wherever 2 lines are intersecting, touching that feasible region. Those 5 extreme points are your optimal solution. We'll know exactly how many standard bags, we'll know exactly how many deluxe bags to send out to production and tell them to make. Do not stop making standard bags till you get to this number. We don't want to pay for the setup cost twice. That's how money gets wasted. So you make exactly this much, you retool, re-dye, set everything up, now you're making deluxe bags. Exactly this minute. Go ahead.
Why is 0, 0 in the feasible region if we have like a startup cost?
I'm sorry, if we have a what cost?
If you have a startup cost of 0, 0 in the
You're going to see a problem where 0, 0 doesn't make sense. And usually 0, 0 is fine, but I recommend never using 0, 0 to determine which way to shade. Grab like a 1, 1 or 100, 100, 100 or something like that. And the odds of this being the optimal solution are fairly slim because this is a maximization problem, and there's no way if you put 0 in for each variable, you'll have 0 objective function value. This will all make sense in a minute. Here's where we are. You ready? What is the, here it is. I said to you, in the old days, if we got lazy, we didn't have computers when I was your age. You had to carry all these cards, punch cards and stuff. But doing stuff like this, we had to do it by hand. And we knew that since there's 5 extreme points, that the optimal answer is there. And if you could plug in each point for the variables into the objective function, you would just know which one is the optimal solution because it's a max problem. It would give you the largest objective function value. What is objective function value? Look at the objective function. If we would take each extreme point, if we had all the time in the world, and we would plug in the first digit of the point into S, the second digit into D, multiply and add them together. And we would do that for each one. And whichever one of those 5 points gives us the largest result, there is your optimal solution. You now can go ahead and tell them how many standard bags and how many deluxe bags they get going on. They've been waiting for you because they're trying to schedule production. But here's a shortcut. I want to remind you, by the way, why we're doing all this graphing here in Chapter 2, building up to Chapter 4. You have softwares where if this business is implementing this or they're using this, you're using software. But again, I want you to know what is happening with that software because when you're in a meeting talking about these, especially these outputs I'm going to show you how to analyze, you need to be able to come up with ideas how you can improve these outputs. If you don't understand how these outputs are generated, you won't be able to make those suggestions you need. This is where your entrepreneurial side comes involved when you're with a company in management. So here's the shortcut. You take that objective function. I'm going to use 10s, what is that, 9d? Are you ready? Let me go back to here. And this is where I lose everybody, so I want to make sure I get everybody's attention. This has been, every semester somebody go, where did you get that number? You pick any number that makes sense and make that equation equal to it, And then you graph it just like you do with any constraint. It's that easy. But on a quiz, someone will go, how do I graph this objective function? It's not equal to anything. You decide what to make. Any number, and it could be, all of you could have a different number. It doesn't matter. When you graph it, it's all about the slope of the line you're graphing. And then you're going to use a straight edge and stay parallel with that line to find the optimal solution. I don't have a very big straight edge, but you're about to see. So some of you will have your objective function maybe lying right here. Some may have it here. But every one of you, the angle of that line will be exactly the same. And that's all you need. Now here's my advice in picking a number. Start with one of these numbers. I usually go with the largest one. And say to yourself, I kind of would like that line to be in here so I could really see it and see the angle. So I say, what would I have to make that equal to when I divide by 10 or I divide by 9? It will put it somewhere around this 200 or 400. Right? So I say, well, 400 divided by 10, or 400 times 10, is 4,000. Does 9 go into 4,000 evenly? Someone help me out there. Wait, I found a number. I already went through this. I like to pick a number that both of these will go into evenly, and we'll put my line where I really can see it well, right here. So I went with 5,400. Again, any number. But don't pick one so low that your line's down here, and you're going, wait a minute, what's going on? You might get it up there a little bit. Give me the numbers here. Let's see. I'm going to go, this is going to be my S. This is going to be my D. We're going to get 2 points. And S, D. I'm making, let's make our S is 0. 5,400 divided by 9. What is that? 600? So 0, 600. I'm making my D 0 now. So I have 5,400. That's 540. I would put my points. Where am I at? 540, which would be right here. And then what's the other one? 600, be right there. Now I draw my line across here. You go across just like that. I need something bigger. Something bigger. Okay? 600, 540, it'd be like that. This is on paper. You're going to have a straight edge. Now this is the key. This is a maximization problem. And as you're looking at these 5 extreme points, you're saying, well, if I go this direction, it's not going to maximize my objective function. It's going to make it really small. So you realize I need to go this direction, so it's got to be one of these 4 points right here is our optimal solution. You ready? You then take a straight edge, and you move towards those 5 points, and you start to leave the feasible region. And when that objective function line is completely out of the feasible region, but it's touching at one little spot, it's going to be one of those 4 points up there. And it's literally telling you, there's your optimal solution. We ready? What was it, 540, 600? So my angle is right, let me get here, about right there. I'm past that point already, aren't I? So now I'm down to these 3. I'm going to stay parallel. Help me out. Am I past another one? Almost. Hang on, I gotta stay parallel. Look at that. I just passed that one. I got these 2 left. I just passed this one. There is our optimal solution. That's the shortcut. It's right there. That spot. All right. I'm going to give you some definitions. This is the feasible region. Your homework says, identify the feasible region. When you get to this point, nice dark lines right here. Do a little shading, put the word feasible region. I want to see some work that you did this line at least once, wherever it's at. Just one time, you got some work there, you graph the objective function line with whatever number you want. Go ahead.
Sorry, I didn't catch what you meant to make it parallel to, like the outside of the feasible region, or where
where I can go. Maybe I'll go and stuff. For example, let's say this is 600, 1, 2, 3, 4, 5, 40. So I'm going to go right there, right there. This is going to do that. I always make my objective function line like this so you can tell the difference between it, but a lot neater. Now I'm parallel to it. If this is a minimization problem, I'm going this way. It's a max problem, I'm going this way. And when you're going that way, at 600, 540. It's gonna, see how it's really reasonable region? Yeah, let's see, parallel. Now, I'm past this one, I'm past that one. It's down to these two. You see parallel? This is it. Look, right there.
Oh, I see what you mean.
See that? I'm now past that one. This whole line's outside the feasible region, except for one little spot. And it's telling you, here you go. That's it, right there. Now, you just found in your homework, step by step, you gotta show me each step. This step is called the optimal point discovery. So you just discovered the optimal point. Now let's go back to this graph right here. Are you ready? There are two lines forming that point. Does everybody see that? Those two lines, we graphed them. It's two constraints. The two constraints, or sometimes there's only one crossing an axis. Sometimes there's three intersecting at one point. But in this case, these two constraints are your binding constraints. I want to say that again because this is important. You're going to have a quiz that says identify your binding constraints, and all it's asking you for is which one of these or two of these are the ones that are crossing, forming that optimal solution. So right here, I follow this line, and it's the finishing, and it's the cutting and dyeing. Finishing and cutting and dyeing. So cutting and dyeing, help me out, 7, is that 7/10 S? 7, is that cutting and dyeing?
Yes.
7/10 S plus D less than equal to 630. And what was the other one?
1/2 S.
Oh, which, is it sewing?
Yeah.
Is it sewing?
Yeah.
Okay. S. Oh, it's finishing. Is that what you just said? Let's go back. Now we got debate going. This is C and D, cutting and dyeing, and finishing.
Finishing, not bad.
I don't know what that. So this is 1S.
Plus 2/3.
1S plus 2/3 D
Less than equal to 7.
less than equal to 708. All right. The question is going to say, identify your binding constraints. You went through all this work, you found that point, figure out which two lines those are, and this is how you identify them. You write the constraint out, binding constraint. This one less than equal to 630. This one less than equal to 708. Now, Chapter 2 lecture started Tuesday with me refreshing a certain math concept. Here's the moment where you use that. You take those two equations that are forming that optimal point, and you either use, remember the three ways, what are they? Substitution, right? Substitution, addition, or subtraction method. All three of them, you have that. I posted the showing examples of all three. Whichever one you felt most comfortable using, you apply to these two lines, and you find the optimal solution. I want to show you here. The substitution method was used. And when you use the substitution method, you would get like D by itself, moving that over. I'm not going to demo because we did 3 different times we did something just like this, but just email me if you want more help on it. And then what you found out was S is equal to 540, D is 252, and you now didn't have to go through all that trial and error. You know money's not going to be wasted. You know exactly how many deluxe bags and standard bags should be made. You tell production, everything's in play now, and they won't stop making standard bags until they get to 540. Then the big cost of switching everything up for the new run, and they make exactly 252 deluxe bags. Go ahead.
The definition of binding constraints.
You ready?
Two lines that are touching.
It's the two lines, it's the two constraint lines that are forming the optimal point. So when we did that whole objective function thing, and we found the extreme point right there, we then had to go back and look which constraints, which two lines is it that's forming that optimal point. Now, I'm going to give you a big hint here. You ready? Binding constraints never have slack or surplus. I want to repeat that. Saves you time. Binding constraints never have slack or surplus. All right. So Here's the deal. Now that we know our optimal solution, the next step on your homework is to plug this optimal solution in for every one of the equations in this linear programming problem. Put the 540 in. I got you on camera. Put the 540 and 252 into the objective function for the S and D and do the math on it. 10 times 540, 9 times 252. If we make exactly that many standard bags and exactly that many deluxe bags, we're going to have the most profit we could possibly have with any combination of standard and deluxe bags is $7,668. If we had used any one of the other extreme points or any point in that feasible region, the best we could hope for is maybe to tie that, called an alternative optimal solution, but there's no reason to spend time searching to see if there is an alternative, because it will not get you not even a penny more than this will. This is the max possible in profit, because we maximize this. 7,668, and then you go for it. And big companies, all of them are doing this stuff, but it's the medium and small companies that haven't implemented this yet. And that's where I always say to my students, go to a big company, see how they're doing this, and then go to a medium company after that, and you bring it to that company, and you're the next president. Because you will save them so much money with every one of these things from every chapter. And it's all these companies are wasting money until they get large enough to go, oh, we better start thinking about, are we making the right amount? Are we ordering the right amount from our suppliers? You know, are we scheduling the right amount to be made? And then they start implementing all of these. So now, you got your binding constraints, you just plugged in the optimal solution, you got your objective function value. That's one of the steps in your homework. Calculate the objective function value just means take the optimal solution, plug it into the objective function, 10s plus 9d, see what it equals. On your homework then it says, calculate the slack or surplus for every constraint. Same thing. You take the 540 and 252, down here, right here. You plug it in for S and D into each one of the constraints. You plug in the let me sure I say this right. The 540 times 7/10, the 252 times D, you add them together, and it's going to equal 630. Well, how do I know that? How do I know that it's going to equal 630? Because it's the, no, almost, you had me. It's the binding constraint. Binding constraints have no slack or surplus. It means when you put the optimal solution on the left side, it's going to equal the right side. There's no difference because it's the binding constraint. Now I put 540 and 252 into the sewing constraint, it is not going to equal 600. And whatever that difference is on the left and right, it's either slack or surplus.
What's the...
If it's, and once you find that difference, I don't care if you made a mistake and subtracted the wrong way, you use absolute value, positive. So whatever that difference is, you then tell me is it slack or surplus. Are you ready? You look at the original constraint. If it's a less than equal, you just found the slack. If it's a greater than equal, you just found the surplus. Anybody hear that? It's that easy. It's the difference. Let me go to finishing. I plug in 540 and 252 here. I do the math. Would I get a difference from 708? Yes or no? A difference. Why? Because it's a binding constraint. I know it's going to equal 708 when I plug those two numbers in. And I put 0, and what word? If I want to identify, 0 what? Slack or surplus for finishing? 0 what? Slack or surplus? Because that's all you got to do. Everybody should be on top of this. You just look and say, is it less than equal or is it greater than equal? Slack. I go to this inspection and packaging. I plug in the 540 and the 252. There's going to be a difference. It's not going to equal 135. And whatever that difference is, you put the amount, and then you tell me, slack or surplus. Alex, slack or surplus on that inspection and packaging. It's not going to be 135. The difference is going to be slack or surplus. Oh, stop it. Help her. Because less than equal. That's all you got to look at. Is it less than equal or greater than equal? Slack or surplus? It's that easy. Sure enough, those two constraints do have slack. I'm going to get it up here. Here's your little definitions for you. And don't forget, I told you to prepare for all the rest of the quizzes by taking that list of topics, putting PowerPoint slide number, putting page number, putting where would I find the help I need. And if you're on Slack and surplus and you can't remember, this is PowerPoint slide 15. On those list of topics, you put PowerPoint slide 15. So refresh your memory while you're taking a quiz. Time is your worst enemy on these quizzes. And sure enough, cutting and dyeing was a binding constraint. You plug the numbers in, you get 630, no slack. Sewing, 120, slack. With finishing, 0. Inspection and packaging, 18. Now, I want to tell you how this is used in business. We're in a meeting. We just did our analysis. We're all talking about this. Look at sewing. What, you know, if we go into this standard deluxe bag, what are we going to do about all these? We're going to have to pay them for all these unused hours, 120? And this is why it's so important that companies do cross-training. Cross-training, cross-training, cross-training. Or you start coming up with ideas how you can utilize these unused slack hours of 120 hours. So either, you know, you have a limited employees where when the sewing employees get free, you shift into another department where there isn't any slack to help out, or you start brainstorming ideas that only need sewing. This is a golf company. You're sitting at the table sewing. Let's do some golf. And that's how it works. That's how it was. That's how we used to do it. That's not a bad idea. Who's willing to take it up and take the time to figure out how this would work out for golf towels? Because they only need to be sewn. We'll get it. We don't have to dye them. We'll get them the color we want. We just got to sew them. We'll get all this huge thing of material. We'll cut them, sew them, embroider. And we just used up our 100. We now have put together where we're not going to waste time in sewing because we have this alternative product now that we can utilize these slack hours. Everybody get it? Everybody with me?
So,
We're going to do another one, Bailey.
if you only have 120 hours, but you're using like 2,000, like, how many
Yeah, that's right. Yeah. Because each product only spends so much time in each department.
Yeah.
You look at how much more time it spends here than it does here, or especially here.
Do you think they'd be making those towels more so for like gifting purposes or like?
That happened to cross my mind because I was on several boards back in my day, and we would always have golf outings. And that would be the thing they would give you at every golf outing is whoever was sponsoring it, you would get a golf towel with their name on it, kind of as advertising. And a lot of companies, when they're making golf towels, they're making them specifically to be sold to distributors who have these magazines where companies can get these gifts that they want. And golf towels are pretty popular. You ready? Here we go. Boom, 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 boom. You read all this at home. I know you walked in. Ooh, look at this. This is chapter 3. We're going to transition to chapter 3 here on Tuesday. Just giving you a hint. I want to point something out. What was it, 540 and 252? Look at this output. You see 540 and 252 anywhere on there? Anybody? Where's it at? Up where?
Like the top.
What's the heading?
Value.
Value. These outputs in Excel have all this exact same information, but they all display it in different ways. So you've got to get used to these outputs, which we're going to really cover in chapter 3. And once you really get the handle on how to read this output, you can read any output from any one of these software. They all give you the exact same information, but they all present it in their outputs differently. And when we get to Excel, it's very different than what this looks like, but it's the exact same information. So start looking at these words. Value, S and D. That is the optimal solution. 540 standard bags, 252 deluxe bags. That's far we're going on chapter 3 right now. I gotta keep going. And I just wanted to give you a hint. Here we go. You ready? Help me out. I want to make some constraints as I read this. This company is making chemicals that they sell to other companies that use in their processes. These chemicals, liquid chemicals, what is this? 2 chemicals. And there's chemical A and chemical B. Oh, the companies they sell these to are making soap and laundry detergents from these chemicals. M&D is the company, and the management said we want to specify a combined production of chemical A and chemical B so that when we decide how many to make of each, they'll total 350 gallons at least. 350, I'm going over here. 350 gallons at least. 350. Give me what's right there. There's only three choices: less than equal, greater than equal, or equal. That's right, at least. No less than. A customer, now this is a big deal in real business. When you have a pre-order before you even put it together, our philosophy used to always say, we must fill the customer's order. We never want to let that customer down. Our sales team got that order in advance. We want to fill that order. A customer ordered 125 gallons of A already. So we know when we schedule production that we are not going to make less than 125 gallons of A because we would let this customer down and back order them. That's not where we're going. Less than equal, greater than equal to 225 gallons. Or equal to, say it again. That's right. We are making at least that many of chemical A because we're making sure I'm filling that order. Product B requires 1 hour of processing time per gallon. Product A requires 2 hours of processing time. You know where we're heading, right? There's probably only so much processing time available. And sure enough, the next sentence, 600 hours of processing time available. That's it. 600 hours. That's a limitation. So you know it's a constraint. I'm going to put the 600 right here. Less than equal, greater than equal, or equal. That's right. We cannot go over 600 hours. That's all we have. We don't have to use them all, but we can't use more than 600. M&D's objective is to satisfy three requirements at a minimal total production cost. Is this going to be a max or a min? Min. Jumps right out even. All right, here we go. There we go. What? Who said that? No, remember, objective function. Never have less than equal, never have greater than equal, never have equal. You've got to keep them out of there. All right? Some of you lost points, I think, on that quiz for putting that in there. Never. And then it says production cost for product A is $2 a gallon. Product B is $3 a gallon. Now we know our variables. How many variables are involved? Two of them, and then what? What are they? A and B. But don't forget, now that we're past chapter 1's quiz, from this point on, if you are going to have to write an objective function, you're going to have to write some constraints, and you have to define the variables. You didn't have to do that for the first chapter, but now you do. So let's look at A, and I want to give you a big hint. Variables are always about how much or how many, or, you know, it's not just, but if you put A equal product A, that's not a description of what A represents. A is maybe something like how many gallons of product A. That is a description. That's what production's waiting for. They're going to make A, they're going to then clean everything up, reset it, and now they're going to make B. And that setup cost, they only want to do it once, not twice. So they need the exact number of A, so they don't have to do it twice. B, same thing. How many gallons of product B should be, product B should be made? There is the questions to be asked. Now we know the two variables, A and B. Let's fill in these constraints. Going back to the 350, it says, management specified that the combined production of products A and B must be at least 500. What is A? How many gallons of A? What is B? How many gallons of B?
500.
Oh, I'm sorry, 350. Thank you. 350 gallons total, at least. So, however many of gallons of A, plus however many gallons of B, it's got to be greater than or equal to 350. Customer already has an order in for 125 of A. B has nothing to do with that 125. A represents how many gallons of A. However many A gallons we're going to make, we've got to fill that customer order. And then the 600 is the amount of processing time. A is not about process. A says how many gallons. So you've got to make a change to A to be the same as the right-hand side, which is in hours. Is it hours? Hours. So for every gallon of A, it takes how long? 2 hours. Plus for every gallon of B, it takes how long? 1. Is that all it is? I don't need to put a 1 there. Less than equal to 600. There, you just wrote the constraints. There's 3 of them. Objective function. A is how many gallons, B is how many gallons, but the objective is to keep costs as low as possible, so we got to change A and B to represent cost. For every gallon we make of A is how much? $2? Plus, how much does it cost for every gallon of B? There's your objective. Minimize those costs. All right. We're right here. Right there. I'm not going to review how to graph, but there is one right here I want you, because you haven't seen a single variable one yet. How do you graph that? There's no B there. You can't put a 0 in for B. When you have a single variable, it goes like this. I got to look here. What do we have? 125. It says A. I like to switch it to equal, just for visual effects, and there's no B. So here's what the points look like. In this case, I'm going to do 3 of them. When you have a single variable there, and you switch this, where is it, greater than equal to an equal, it's basically telling you, whatever you decide B is, pick any number out of the air, as long as A is equal to 125. So I'm going to go 125. Give me a number between 100 and 200. Anybody? 136 or whatever that was. 125. Give me a number between, I don't know, 200 and 500. 240. It does not matter as long as 125. I'm going to go with 100. As long as 125 is in the S. And it's going to be a straight line. Where's S? Right here? Where's 125? Is this 100? Right here? 125, 0. 125, 100. 125, 240. 125, 136. That's tough. Almost there. Let's figure that one out. Right there. And then extend. And it's a straight line. This is A is greater than or equal to 125. I want to figure out which way to shade. I'm going to pick any point to the left or right. All right, right here, 100, 100, but there's no D, so I put 100 in for A. Is it greater than equal? Is that point greater than equal to 125? No. So it's saying don't shade that way. You're shading this way on that line. Get it? That's the only one you haven't seen. You've seen this before. It's just going to shade the other way compared to the last problem. You've seen this one before. This one's traditional, shading the opposite way of that one. And so you get all 3 lines there. You get your little arrows. You then say, where are all 3 shades overlapping? Right there. There. This one's going that way. This one's going that way. This one's going that way. We got overlapping here all over the place, even there. But only place where all of them overlap is that area right there. Let me stare at this fiddle. Right there. All right, ready? Ready? How many extreme points? Yes. Say it again. 3. That's all. Now you got it. It's any place 2 lines are crossing that are touching that feasible region. There's 3 extreme points. One of those extreme points is our optimal solution. All right. What's the objective function here? Let me go back here. 2A, 3B. All right. 2A, 3B. Don't want to duplicate that, but let's see. I want my objective function to be somewhere. It doesn't matter anywhere, but I'm just looking at numbers. I got 300 to 200, 200. And so, as you can see, arbitrarily picked a number out of the air, and it happened to be 800 in this case. Put a 0 in for A, 800 divided by 3, whatever that is. Help me out. Put a 0 in for B, 800 divided by 2 would be 400, and your A would be right here at 400, and your B would be at, what is it, 266, right here. All right, let me get my straight edge again. Here's the tough part. This is a minimization problem. You've got to almost say, would this be, if this were the extreme point, this is approximately, I don't know, 250, 125, or 100. Just kind of say to yourself, if I put that into the objective function, will that give me the lowest result? Well, let's look at this one. Well, we know that's 125. And this is, let's just call it, I don't know, what is that, 240. If I plug that in, will it be a lower number? Will it be a lower number or a bigger number than that point? And then look at this one. And you realize that the farther this direction gives me a lower objective function value. So the extreme point where the optimal solution is probably right in here. It was 260 something, and what was the other number? 400? 400, 261 again. 267. Here we are. I'm going to go right along here. 400, 267. That's here we go. Let's see, I'm even up here. Doesn't matter. Now, look at this feasible region. It's going to be one of these 2 points. I got to get back. Okay, good. Okay, ready? Where was the very first one touched? Where was the very first one touched when the whole line is outside? See, there it touches, and the line's on the outside. If the teeter-totter on that one, it's in the feasible region. That can't be it. And then look at that one. Look at this angle. Right there is the last one it touches if you're going this direction. That is the extreme point where your optimal solution is. This one is the processing time, that 600 one, right here. And this other line, what is it? Which one's that one? 3 something? You know that close, which word? 380? 350. What are these 2 constraints called? Binding constraints. Binding constraints. If I were to put the optimal point in for A and B for these 2, how much would the slack or surplus be for this top one?
0.
0 what though?
Surplus.
Surplus. Alex, you ready? Say it again. Binding constraints. That's these 2 right here. So if I were to plug the optimal solution into this one, well, and would there be a difference? Yes or no? Exactly. This would be 600. That would be 600. So there would be no difference. It would be 0. But would it be slack or surplus? Look at it. Slack or surplus, Albert? Slack. Because less than equal is slack, greater than equal surplus. Each of those would be 0. And when I plug the optimal solution into this non-binding constraint right here, it's not going to equal 125. Right there, A is not 125. We're about to find out what it is. But whatever A is there, look at that A, yeah, A and 125, that difference is either slack or surplus. You tell me, is it slack or surplus? Surplus. So let me go past 5. We got an in-class assignment in 9 minutes or 11 minutes. All right? We go ahead and we find the 2 constraints, we do the substitution method, and we find, where are we at? Is that the optimal? The optimal solution is 250 for A and 100 for B. 250 and 100. A and B. Go back to the constraints. Look at that second constraint. A is greater than or equal to 125. Look at the optimal solution. 250 and 100. You tell me, what's the difference between the left-hand side and the right-hand side on that second constraint? Double. So he's saying, because A is 250, and the constraint is A is greater than or equal to 125, the difference is going to be 125. Alex, you ready? Yeah. Really? Slack or surplus on that 125? All right, thank you. All right. And then, no reason to waste time. This is a timed quiz. This is a timed final exam. You're going as fast as you can. You remember that all binding constraints are 0. You don't need to show the work on those 2. You're going to show me you remembered something. You're going to go 0. I'm on the first one, 0, and you tell me 0. The first one, top one, 0. Oh, yeah, surplus. And the last one, you're writing 0 without showing any math because you know it's a binding constraint. And that last one, 0 what? Slack. You just saved a ton of time on it. All right, let me look at my notes. We're darn close. No, we're there. Here's my questions. You get this on a quiz. In your homework, actually. That's a great idea. Here we go. Here's your homework. Let me do this. Let me get it bigger. Here's your homework. What? Well, that's your homework.
This is due Tuesday.
When you go home, homework. When does it due?
Tuesday.
Exactly. Here's your homework. There's the objective function. Only 2 constraints. You got an easy thing going on here. A, find the optimal solution for the linear programming problem above, showing all detail of work. I know some of you want to jump into Excel right away. We're not there yet. Just do it by hand. It's so much faster. You don't have to give me some fancy graph or some. If you want to, if that's your thing, yeah, please do it. But I'm trying to save you some time. If you want to do it by hand, that's absolutely what I expect from you. B, show and label the feasible region. We talked about the feasible region, right? The description of the feasible region, where all the constraints shaded overlap. All of them overlap. C, how many extreme points are on that graph? You can tell me where every point is touching that feasible region where 2 lines cross. Graph the objective function. I know right now I can hear you. Wait, what's the objective function equal to? How do I graph it when we have no number? You pick a number out of the air. Any number. I mean, I showed you a way to pick one that helps you a lot, but it could be any number because you're just trying to get the angle of that line. E, identify your binding constraints. Oh, I'm sorry. Graph your objective function. Now you just found the optimal point, so you can tell me which constraints are binding. You just write them out like this. Binding constraints. You put the 2 constraints or 1 or whatever it is. Blah, blah, blah. Identify the values of the optimal solution, because you're going to take these binding constraints, you're going to show me that you can either do the substitution method, the addition method, or the subtraction method to find that optimal solution. I want to see that you know how to do at least one of those to get this answer. And then calculate your objective function value. You just found the optimal numbers, you plug them back into the objective function and do the math and get a total. Calculate the slack or surplus for each constraint. You take the optimal numbers, you plug them into each constraint, you see if there's a difference, and you say 0 or whatever the number is, slack, or the word surplus, based on the less than or greater than. Does everybody understand what's asked for this homework? You feel like you could do this? I tell you, if you wait till Monday or Tuesday morning to do this, I know some of you are going to go, oh man, I understood it when I was there, but why? It's like it just leaves you. It leaves you. So attack this homework today, tonight. Get it over with. While it's fresh in your mind, this will only take you like 45 minutes. Any questions? Anything you don't understand that you don't think you're prepared to be able to do this? So we're good for the in-class? We're ready to go? Yeah.
How do you know which of the, what extreme point is like the correct one to choose again?
Everybody hear me saying? He said, whoa, come on. He said, how would you know which constraints to use, which one of these extreme points is the optimal one? You're going to graph that objective function line, and you're going to get an angle, and you're going to start, and you don't have to show me this, but this is how you would do it. And you're going to go like this, and the whole line's got to be on the outside, but touching one of these points. There's 2 places this line was on the outside. It was touching there, and then it was like down here like this, touching right here. See, the whole line's out here, touching there. But there's no way that line could touch that one, and it would be going across the feasible region, so that can't be it. Then you realize this is a minimization problem.
So that's how it is.
Yeah.
If there's like 2 that
Yeah,
are only one.
and some of it's real obvious. You don't even have to. Yeah. Any other questions?